Hello, I welcome you all to this channel again. So now I have come with a very simple concept, coordination complexes as a redox reagent. I could find some questions related to this in previous CSIR NET chemical science examination. So I just stopped taking this. So in this presentation, I'll be just giving you information about very basic aspects of oxidizing agents, reducing agents, and what is exactly oxidation, what exactly is reduction. Those aspects will be giving. And at the end, as usual, I'll provide you 3 questions. Those have appeared in previous year CSIR NET examination. And in the next video, definitely I'll provide solution for those 3 questions. Okay, let us begin with the back to this previous slide. See, here I said zinc, it is undergoing oxidation, right? Which simply means that oxidation state of zinc solid, it is 0. It is changing from 0 to +2, which is increase. It is increased, right? So therefore, this species, it is undergoing oxidation. So here it is changing from copper 2 + copper solid. Copper solid oxidation state, it is taken to be 0. So 2 + 0, it is definitely decrease. So decrease in number, it is considered to be reduction. So oxidation and reduction in terms of oxidation number and oxidation number, it is simply this: increase in oxidation number is oxidation, reduction always it results in decrease in oxidation number. Then we should know even this fact, what exactly is oxidizing agent and what exactly is reducing agent. Oxidizing agent, it is simply a species which oxidizes some other species. Usually I take this analogy, or usually just for in a lighter note I say this, right? So see, LIC agent or a life insurance agent, what he does is he makes polish to others. Similarly, oxidizing agent, it is species which oxidizes some other species, right? And but in turn it undergoes a reduction by itself. This is very important thing which should be kept in mind. See, oxidizing agent, it should oxidize some other species. It simply means that it should remove electrons from some other species. If a species, it is removing electrons from some other species, it simply means that the species which is removing electrons, it is taking electrons by itself. Therefore, if it is taking electrons by itself, it should undergo reduction. Here you can clearly find it. See, this is permanganate ion, MnO4 minus ion, where Mn, it will be in +7 oxidation state. In acidic medium, it can act as oxidizing agent. So by definition, if it can act as oxidizing agent, it simply means that it can accept electrons from some other species, right? And by accepting electrons, Mn, it changes its oxidation state from +7 to +2. It simply shows that it is accepting 5 electrons. So it is accepting 5 electrons from some other species, and that's how that some other species it is getting oxidized, whereas this one it is getting reduced. So oxidizing agent, again I'm repeating it, remember, it oxidizes some other species, in turn it undergoes reduction. Even in the same even the same thing it can be observed in this example too. So these are two very important oxidizing agents, or two important transition metal complexes which can act as oxidizing agent. The other one is dichromate ion, or even chromate ion for that matter, can be taken here, right? So chromate ion, it is just CrO4 minus. It's a dimeric form approximately. This Cr2O7, it's a dimeric form. It is also very popular or very important oxidizing agent. Here oxidation state of chromium, if you compute, it will be 6+, right? In acidic medium it can act as oxidizing agent, and if it acts as oxidizing agent, again same thing, what it can do is it will accept electrons from some other species. The other species, it gets oxidized, and this, by accepting electrons, it gets reduced to 3+. So here you can find +7 to +2. So it is a decrease in oxidation number, which means this is a reduction reaction, right? So here also 6+2 3+, which is decrease in oxidation number, which means this species, dichromate species, it is undergoing reduction in this case. So oxidizing agent, it by itself undergoes reduction. Same line, what is reducing agent? Reducing agent, it should be a species which reduces some other species. Oxidizing agent, it oxidizes. Reducing agent, it reduces some other species, right? And in turn, it should undergo definitely oxidation here. If it is reducing some other species, it simply means that it is donating electrons to some other species, so that the some other species, it is accepting electron and it is undergoing reduction. Whereas this species, right, if it is donating electrons to some other species, it should be losing electrons, and in turn it should have undergone oxidation. Here you can look at one classic example, carbon monoxide. If it is acting as reducing agent. In fact, it is a reducing agent, it can act as a reducing agent. In iron metallurgy, at a particular temperature condition, carbon monoxide can act as a reducing agent. So carbon monoxide, it is getting converted itself into carbon dioxide. Now the oxidation state of carbon, if you look at here, it will be 2 plus, here it will be 4 plus, right? So now what has happened is this has lost 2 electrons, so therefore its oxidation state, it has changed from 2 plus to 4 plus. So in turn it has released electrons to some other species, and therefore we can say that it has undergone oxidation by reducing the other species. So these are some very important basic aspects that you are supposed to know to solve the following questions. Of course, some more inputs are also required, but what I expect is, I never believe in the fact that everything it should be taught and then you should solve questions. No. So what I expect is minimum you should know, and from that minimum you should be able to solve all those questions, right? And 3 questions you can find it here. I request you to solve or try all these questions, and solutions for all these questions will be provided in the next video. So this first question, which has appeared in June 12th CSIR NET, it was asked for 2 marks. Which is the strongest oxidizing agent? You can just try this. The second one, again, it is about oxidizing power itself. Now here they have given 3 different species, and you are supposed to identify the order, which is strongest, which is weakest, in that way. You can just take a try, and on what logic exactly it is to be solved, you can see it in the next video. So I sincerely request you to pause the video and try to solve these questions before you go to the next question. Okay, last question, it is this. In fact, this is interesting question, right? So in fact, it is something about H2O2, but still the question it has been given here is because if you know the basic definitions of oxidation and reduction, so even if you know the capability of H2O2 and the redox reactions of H2O2, just with your basic knowledge, this question it can be answered, and I request you to try this also. Fine, these are the questions. We shall meet in the next video again with the solutions for all these 3 questions. Thank you.